Let's review adjusted present value with Python. So import numpy SMP, standard one, and then calculate. First, we have to calculate unlevered free cash flow (UFCF). In order to calculate UFCF, we need EBIT, tax rate, depreciation, and delta, and WC and capex. So this function calculates unlevered free cash flow (UFCF) and its argument input variables are EBIT. Float is earning before interest and taxes, and tax rate float is a corporate tax rate. Depreciation, it is the depreciation expense, and delta NWC is change in net working capital, and capex is capital expenditure. And if you input this one in this upon this argument, this function generate unlevered free cash flow. So return EBIT 1 minus tax rate plus depreciation minus delta net working capital minus capex. Same to the formula we learned. Now we calculate present value of UFCF, and then input variable is UFCF left, and then RU terminal value and the discount period. So it calculates the present value of unlevered free cash flow VU. This argument is UFCF list of unlevered free cash flow values for each period. RU is unlevered cost of capital, and the terminal value float terminal value at the end of the forecast period, discount period, number of period for which UFCF is forecasted, and return float unlevered value. So initially present value, let's initialize present value of unlevered free cash flow 0, and then we adding them. Okay, so here we add from period 1 to the terminal period, so that P present value of UFCF is cumulative sum of each item in the list. Of course, we have to discount with unlevered cost of capital 1 plus RU. Okay, and then once we add intermediate cash flow, then we have to add the terminal value. Again, we discounted terminal value with 1 plus RU star discount period. Then it returns present value of UFCF. Now we need a function to calculate terminal value. Terminal value, in order to do that, we need last year UFCF, RU, and growth rate. So it calculates terminal value using the perpetuity growth model. Here argument is the last year UFCF float UFCF in the last forecasted year, and RU is unlevered cost of capital. Same growth rate is the constant growth rate for UFCF beyond its forecast period. Simply assume it is constant, and it return terminal value. So, well, from last year's UFCF, and then by multiplying 1 plus growth rate, we have this year's terminal year UFCF, and then divided by cap rate, RU minus growth rate. Then it becomes the value. Now we need a function to calculate tax shield. Calculate tax shield. Well, you need interest expense and tax rate. So this function calculates the tax shield from interest rate expense. Argument is interest rate expense, and then tax rate. Return tax shield. Simple. Well, interest rate, interest expense multiplied by tax rate. This is the amount we save. Now we calculate present value of tax shield. So here we have tax shield list RD for convenience. Well, again, well, it is cost of that. We may not want to use cost of that. More generally, we want to use the, actually, we can change this one, tax shield RTS. Okay, RTS and discount period. Calculate present of tax shield, and we need tax shield list, and then we need RTS, cost of tax shield. Okay, let's update code. tax shield. And the discount period is number of periods for which tax shield are calculated. So return float present value of tax shield. So PV tax shield 1 plus range discount period, and we cumulative sum of the present value of tax shield by adding present value of each tax shield over time. Okay, then it becomes this one. So calculate APV, then with the VU present value of tax shield, we can simply sum them. Okay, here calculate the adjusted present value. So argument is that, well, VU unlevered value, PV tax shield, present value of tax shield, and then return adjusted present value, which is simply sum VU value of unlevered form and present value of tax shield. Okay, let's put realistic number. Okay, so input data, let's say tax rate is 25%, unlevered cost of capital 10%, cost of debt is 5%, and then let's say RTS is same to RD. Okay, let's make it same. Okay, cost of tax shield and growth rate is 2%, and we have a revenue stream and the operating expense, depreciation, and interest rate expense. Therefore, EBIT is our revenue is, well, edit EBIT is revenue minus operating expense minus depreciation. So, well, we have this one. This R minus OE minus D for ROED in respectively their revenue, operating expense, and depreciation. So we generate the list of EBIT and balance sheet data for NWC. NWC net working capital this year, let's say this one. The initial net working capital is 20. So delta NWC change of this one. So net working capital year end minus initial NWC plus NWC year I minus NWC year end I minus 1. So we have to do this one for I in range for this period. Then it becomes a delta of net working capital. Next, let's say capital expenditure is 15, 15, 15 same. Discount period is 3, and UFCF list is, now we can calculate UFCF. Well, calculate UFCF this way. Okay, so we apply this function over here, UFCF, this function over here. We calculate unlevered free cash flow. So calculate UFCF, we plug, well, EBIT, tax rate, depreciation, delta, net working capital, capital I, and we append it and create the list. And the print, we can print unlevered free cash flow, and then calculate unlevered beta. Terminal value is year 3. UFCF is calculate UFCF at the terminal period, which is EBIT, the last item, EBIT minus 1, which is the last item, and then we make it grow 1 plus growth rate, and then we input tax rate and depreciation. Okay, then we have terminal value. Okay, terminal value year UFCF, and then terminal value is simply calculate terminal value is, we have this one using UFCF at year 3, and then therefore unlevered form better calculate PV UFCF as UFCF list plus UE RU cost of unlevered capital, unlevered form, and terminal value and discount period, right? And then we can print out the terminal value, and then we print out unlevered value. Now we calculate the tax shield. For tax shield list, initialize is empty, and we keep adding that. We fill the list with calculate tax shield and tax shield list. So we have a list of tax shield like this one, and then present value tax shield. here we have to use RTS. Okay, and then PV tax shield, calculate the PV tax shield. Let's check tax shield list, RTS, discount period. Okay, done. And then calculate adjusted present value is, well, we can sum them and they look right. So we'll run it. Well, unlevered free cash flow is this one for the next 3 years, and then terminal value is $274 million. Therefore, unlevered value is the discounted this one, which is 251.949 million. Now we have a series of tax shield. Present value of tax shield this one. The tax shield is small, so adjusted present value is 252.520 million.